This is Mrs. Doris with Lesson 7-5 entitled Rational Exponents and Radicals. Our objective in this lesson is that you will be able to rewrite expressions involving radicals and rational exponents. We're going to begin with a few definitions. All right, let's begin. Under definitions, you'll see radical. This is short for radical expression, and a radical is any expression with this symbol in it. All right? And that is what we call a radical. The radicand is the number or variables underneath the radical sign. And the index is the root of the radical. All right. Actually, I'm going to reword that. Let's redefine that as the degree of the root. All right, now this will make sense here in a minute, I think, with our example. Okay, this entire expression right here is what we would call a radical, or a radical expression. All right, in our example, the A is the radicand. Okay, and the N is the index. All right, or the degree of the root. Now, in a square root, such as the square root of 25, we know that we're looking for a factor that multiplied by itself gives you 25. So we can put a 2 there. 2 is the degree of the root because we're looking for two factors multiplied together to give 25, but we don't show it. And so it's kind of like the exponent of 1 in an exponential expression. We don't show it, we take that as being understood. And the same is true with a square root. If it's something other than a square root, such as a cube root or the fourth root or the fifth root, then we have to show a number for the index. All right, so problem 1, finding roots. What is the simplified form of each expression? All right, our first example, the cube root of 27. And we're going to write these out. 27 can be written as 3 times 3 times 3. So the cube root of 27 is 3. 3 is used as a factor 3 times in order to get the radicand of 27. In our next example, we want the fifth root of 32. Well, 32 is equal to 2 times 2 times 2 times 2 times 2. So the fifth root of 32 is 2. In the next example, the cube root of 64, 64 can be written as 4 times 4 times 4. So the cube root of 64 is 4. And our next example, we have the square root of 36, which of course, as you will recall, we don't have to show the 2 there. It is not incorrect to do so, but typically you have not seen that. So again, we're looking for a factor that multiplied by itself 2 times gives you 36, and the answer to that would be 6. All right, in this next examples, I want you to look for a pattern, and I want you to use a calculator if necessary. Pause for a moment and get a calculator and fill in the blanks, and then we'll talk about the key concept. All right, as I hope that you have found here, 49 to the 1/2 power is 7, and the square root of 49 is 7. 8 to the 1/3 power is 2, and the cube root of 8 is 2. 16 to the 3/2 power is 64. And the square root of 16, which is 4, cubed is 64. And 27 to the 2/3 power is 9. And the cube root of 27, which is 3, when we square it, we get 9. Well, as you notice, and with the colors I've tried to emphasize it, we have some equivalent expressions. 49 to the 1/2 power is the same as taking the square root of 49. So, in our key concept, the equivalence of radicals and rational exponents, if the nth root of a is a real number, and m and n are positive integers, then a to the 1/n power is equal to the nth root of a. This right here, good examples are the top two problems. All right, and a to the power of m/n is equal to the nth root of a to the mth power, or the nth root of a, quantity to the mth power. All right, so examples of this can be seen in these two examples. All right, so problem 2 is converting to radical form. What is each exponential expression in radical form? All right, so our first one, remember the denominator of our exponent is the root, or the index of our radical expression. A is our base, and the 5 says that we want to take it to the 5th power. All right, in our next example, the 1/3 applies only to the x, so 5 is going to stay outside of the radical expression, and we want the 3rd root, or the cube root, of x. All right, in our next example, I think it's going to be helpful to us to write it out so that you can see how this works. Once again, the denominator is the index of our radical. We have 54y, and I have to show the 54 in parentheses because it is entirely taken to the second power, which is the numerator of our exponent. Now, in this situation, it's going to be best if we write out the factors of 54. We know that 54 can be written as 9 times 6. And 9 times 6, well, let me go ahead and do that. We have 9 times 6, and then times y. And let's go ahead and let's go square it. So we could write it again as 9 times 6 times y. All right, now, all right, I'm going to back up here for just a second, and we're going to write this a little bit different way. All right, and I'm actually going to go back all the way. We're going to rewrite 54 as 27 times 2, y. The reason that we are doing this is because in our exponent we're going to be finding the cube root, and we can take the cube root of 27. So applying our exponent to each of these factors, we would have 27 to the 2/3 power times 2y taken to the 2/3 power. All right, 27 to the 2/3 power. We're looking for the cube root of 27, which is 3, and then we square that, which gives us 9. So this expression right here is equal to 9. Now we'll write the rest of it using our cube root of 2y and squaring that, and that is our expression. All right, problem 3, we're going to convert to exponential form. Write each radical expression in exponential form. All right, so to begin with, the cube root of s squared can be written as s to the 2/3 power. Remember, the numerator raises s to the second power. The denominator is the index of our radical expression. On our next one, we have 12, and then x will be written to the power of 4 over 3. 4 is the exponent, 3 is the index of our radical. In our next problem, this is the square root, so we're going to write 4y, and 5 is the exponent. We're taking the square root, so it'll be 5 over 2 for our exponent. And then finally, we have 256, and let's see. All right, the last problem, we're going to write this as 256a to the 8th power, and then the 4th root tells us that we're going to take 1/4, raise this expression to the 1/4 power. So distributing the 1/4 to each factor, we're going to have 256 to the 1/4 times a to the 8 times 1/4, which would be 8 over 4, which reduces to 2. 8 times 1/4 is equal to 2. Now, we can take the fourth power of 256. That is 4. So we have 4a squared for our simplified answer. All right, and problem 4, using a radical expression, using the formula for metabolic rate, R equals 73.3 times the fourth root of m cubed, what is the metabolic rate of a man with a body mass of 75 kilograms? And of course, capital M stands for our body mass. So we're going to take 73.3 times the fourth root of 75 cubed. All right. Simplifying this expression, we're going to have 73.3. 75 cubed, we may prefer to write out as the fourth root of 75 is 5 times 5 times 3, and we're going to have that 3 times. All right, I think we're going to take the easy way on this one. This is a great calculator problem, and that way we won't spend too much time with our calculations. So we're going to take 75 and raise it to the third power, which is 421,875. Now let's go ahead and evaluate. We're going to take 73 and 3/10 times the fourth root, and to put in the fourth root in your calculator, you want to put in the index first, 4, then hit the second button and the caret button, because right above it you're going to see a symbol that looks like this. All right, and then we're going to put in our radicand, 421,875. Hit enter, and you should get an answer like 1,868. And I'm going to change this to is approximately equal to. There is a decimal that comes after it, but it is a small decimal. So the metabolic rate of a man with a body mass of 75 kilograms would be 1,868. Metabolic rate is the number of calories that a person with that body mass will burn in a day. So we'll label our answer calories per day. Please work on the assignment. We're going to do the 7-5 practice, and if you have questions, please do not hesitate to ask.